Welcome back, mathematicians. In this video, we are going to solve more oblique triangles. And a quick reminder, to solve an oblique triangle means to find the lengths of any unknown sides and the measurements of any unknown angles. In this case, we are going to be given all three sides of the triangle, known as side, side, side. We will use the law of cosines to solve triangles in this case, which states, for a triangle with sides A, B, and C, and opposite angles A, B, and C, respectively, and there are three versions. I'll read the first one. It says a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. What you probably observe is that there's a pattern with these three versions of the formula. The pattern is the square of one side of a triangle, which in this case would be either abc squared on the left side of the equal sign, equals the sum of the squares of the other two sides, which would be this part of the formula for each version, minus twice their product times the cosine of the included angle, which would be this version. Regardless of which version you use, you'll either be solving for an unknown side, which is the variable on the left side of the equal sign, or an unknown angle. Let's now use this information to solve for the following triangle. And I'm going to draw a picture to illustrate what we have and what we need to find. What we have is side A, which is equal to 9 units, and corresponding angle A, which is unknown. We have side B, which is 7 units, and corresponding angle B, which is also unknown. Finally, we have side C, which is 10 units, and corresponding angle C, which is unknown. You have the freedom of choice on which angle to solve for first. I chose angle C, so that means that I will have 10 squared on the left side of the equal sign. This is equal to 9 squared plus 7 squared minus 2 times 9 times 7 times the cosine of angle C. I now need to solve for angle C, and to do that I'm going to start by subtracting 9 squared and 7 squared to both sides. This gives me 10 squared minus 9 squared minus 7 squared is equal to negative 2 times 9 times 7 times cosine of angle C. Next, I'm going to divide by negative 2 times 9 times 7. This gives me 10 squared minus 9 squared minus 7 squared divided by negative 2 times 9 times 7, and that's equal to cosine of angle C. Finally, I'm going to take the inverse cosine of both sides. So now we know that C is exactly the inverse cosine of 10 squared minus 9 squared minus 7 squared all over negative 2 times 9 times 7. We should now use our calculator to find the approximate value of angle C. Now I'm going to write out exactly what you should put into your calculator in order to get the value for angle C, and that would be inverse cosine, which is typically second cosine. This will open up automatically a parenthesis. You need to open up another parenthesis, then type in 10 squared minus 9 squared minus 7 squared, close parenthesis to group every term in the numerator together, divided by, open parenthesis again, negative 2 times 9 times 7, close parenthesis, close parenthesis. When you enter this into your calculator, you should come up with an approximate value of 76.2 degrees. I now need to solve for angle B or angle A, and it really doesn't matter which one you choose. I chose angle A, so therefore I would have 9 squared is equal to 10 squared plus 7 squared minus 2 times 10 times 7 times cosine of angle A. I'm going to solve this formula for angle A in the exact same format, starting by subtracting 10 squared and 7 squared to both sides. So this gives me 9 squared minus 10 squared minus 7 squared is equal to negative 2 times 10 times 7 times cosine of angle A. I'm then going to divide by negative 2 times 10 times 7. This will give me 9 squared minus 10 squared minus 7 squared divided by negative 2 times 10 times 7, and this is equal to cosine of angle A. I'm then going to take the inverse cosine of both sides, and this will give me the exact value of inverse cosine of 9 squared minus 10 squared minus 7 squared over negative 2 times 10 times 7. Putting this all into my calculator and evaluating, I get approximately 60.9 degrees. And finally, I want to find the value of angle B, and angle B will be equal to 180 degrees minus the known angle of C, which is 76.2 degrees, minus the angle A, which is 60.9 degrees, to give me a difference of 42.9 degrees. I have now successfully found the unknown values of angle A, angle B, and angle C. Alright guys, good luck!